Have you ever heard of quantum mechanics? Probably. Have you ever heard of quantum superposition? Maybe. Do you know what quantum superposition means? Well, let's find out. Imagine flipping a coin. In our world, it's either heads or tails. But in the quantum world, that same coin could be both heads and tails at the same time. This strange idea is called quantum superposition, one of the most mind-bending principles in physics. You might be thinking, it's just a coin. It can't be in two places at once. And you'd be right in the everyday world. But at the quantum level, the rules are different. Particles like electrons and photons can exist in multiple states at the same time. In Sindua, we see a light bulb turning on and off, a ball here and there. But for quantum objects, things are different. They can be in multiple places at once. That's what we mean by quantum superposition. In Sintiga, a single quantum particle splits into multiple versions. Each version represents a different state of the particle. For example, the particle might be in two different places at once. Or it could be spinning in two different directions. The key point is that until we look, the particle exists in all these states at the same time. But the moment we observe it, it collapses into just one reality. To make sense of this, physicist Erwin Schrödinger came up with a thought experiment. Imagine a cat inside a box. Schrödinger's cat is alive and dead at the same time. It exists in both states until we open the box and observe it. Then it collapses into one reality. In Singlima, we have the famous double-slit experiment. Electrons are fired at a barrier with two openings. You might expect to see two distinct bands of electrons on the screen behind the barrier. But instead, the electrons form an interference pattern, as if each electron went through both slits simultaneously. The act of measuring or observing the electrons causes this wave of possibilities to collapse into a single outcome. This isn't just some strange theory. It has real-world implications. Quantum superposition is the basis of quantum computing. Unlike classical bits that are either 0 or 1, quantum bits or qubits can be 0, 1, or both at the same time. This allows quantum computers to perform calculations that would take a lifetime on a regular computer. The ability to harness superposition gives quantum computers an incredible advantage. It allows them to perform multiple computations in parallel, exploring many possible solutions at once. This is particularly useful for solving problems that are intractable for classical computers, such as breaking encryption algorithms, simulating molecular behavior for drug discovery, or optimizing complex systems. But how does this actually work? How do you store and manipulate quantum information? It all comes down to the qubit, the quantum bit. Unlike a classical bit that is a definite 0 or 1, a qubit can exist in a superposition of both states. This is often represented mathematically as a linear combination of the two states, say alpha 0 plus beta 1. The coefficients alpha and beta are complex numbers that determine the probability of the qubit being measured as 0 or 1. But how do we write this in a more visual way? Enter the Bloch sphere. Qubits can be visualized as points on the surface of a sphere. The Bloch sphere provides a geometric representation of the possible states of a single qubit, where the north and south poles represent the states 0 and 1 respectively. Any point on the sphere represents a valid quantum state for a single qubit. The Bloch sphere is particularly useful for visualizing operations on qubits, such as rotations and reflections, which correspond to physical manipulations of the qubit state on the sphere. But that's not all. Superposition also plays a crucial role in another fascinating quantum phenomenon: entanglement. Entanglement is a correlation between the states of two or more particles. If two particles are entangled, the state of one particle cannot be described independently of the other, no matter how far apart they are. If you measure the state of one entangled particle, the state of the other particle is instantly determined. This connection between particles is often represented visually as a line connecting the particles, emphasizing their shared state. Now let's take a step back and reflect on what we've learned. Quantum superposition and entanglement are fundamental concepts in quantum mechanics that challenge our classical intuitions about reality, They suggest that the universe is more interconnected and mysterious than we might think. As we continue to explore these concepts, we open ourselves to new possibilities and a deeper understanding of the world around us. We hope you enjoyed this journey into the fascinating world of quantum mechanics. We'll be back soon with more videos to help you understand the amazing science that shapes our universe. Don't forget to subscribe so you never miss out on our latest adventures. As we look to the future, we're reminded of the profound words of Richard Feynman, who said, "No one can predict the future, not even a physicist." The world of quantum mechanics reminds us that reality is often stranger than even our wildest imaginations. Who knows what wonders and mysteries lie ahead in our exploration of the universe? But one thing is certain: the more we understand the laws of nature, the more we uncover the beauty and complexity of the reality we call home.